Hi, we're going to be going through the step-by-step process of converting scan data acquired by the FreeScan combo, metrology grade handheld 3D scanner by Shining 3D, into Geomagic Design X. From importing the STL to creating a solid parametric CAD model that can then be exported and used for whatever your application happens to be. So first things first, we imported the scan data. We selected a plane with the smart brush. Plane assignment was made with the plane command. The plane was selected and the drawing was started, which allowed us to accurately take the outer measurements by enclosing the entire area. We selected with the circle command. The drawing was then completed. A point was created at the center by selecting the circle with the point command. The outer roller surface of the part was selected with the smart brush. So then region assignment took place, and a vector assignment was made by selecting the region. All procedures for alignment were then completed. So then we started the alignment. We then selected the plane. A vector and a point were created. We selected the origin as the target. Double checked to make sure the alignment was correct. And so since the alignment was correct, we were able to delete all of the reference geometry that we created because it was only created for alignment. We assigned a region to the outer surface of the part with the smart brush. We then selected the cylinder region and assigned a vector. We chose the plane passing through the middle to start the drawing. We made a vector selection to measure from the desired cross-section. The appropriate cross-section was selected by rotating. The vector was then copied by mirroring. We then converted this to an axis line. One side was then drawn with the automatic drawing command. Some parts weren't rendered properly, so we adjusted the sensitivity. That part of the process was then completed. We deleted the excess parts that we created. We completed the other side through mirroring. Now that the mirroring's done, all the unnecessary parts were deleted. We created the additional missing parts by lengthening. And then we rotated to the center with the rotate command. We then selected the flat surface and started to create the slot region. The slot region was quickly drawn by selecting the slot command, and then we cut in both directions. We started the drawing by selecting a flat surface, and then we started to draw with the circle command, forming a radius. Suitable size was found and applied to all edges. Excess parts were pruned. We copied the center circle for joining. We then created a plane with the smart brush tool to acquire the maximum border. The plane was then selected as the boundary by joining. And we started drawing the holes. The circles were drawn quickly by selecting the circle command. We then had to input the measurements, and then we cut in both directions. We then began the beveling process by selecting the edges and performed an automatic calculation to obtain the correct size. We assigned a plane to determine the border, and the drawing was started by selecting a flat surface. We then completed the drawing for the required area, And then we copied the drawing from the center so that we could join it. So now that the drawing is completed, we got rid of the excess parts. The plane is selected for the boundary by joining. We started the drawing by selecting a flat surface. We then checked for cross-sectioning at the appropriate places. Radiuses were then calculated by drawing the appropriate drawing. We then selected the other surface and got help from the previous drawing. The appropriate relations were then given, and we eradicated the excess. We then acquired the radius dimensions. We selected the loft command for cutting. We selected 2 drawings, and then we cut, and all the excess was then deleted. The drawing was then started by selecting a flat surface. The desired part was completed with automatic drawing. We then performed cutting by creating a closed area. We then assigned a region to the surface to fix the appropriate plane. Plane assignment was done with a smart brush. A section was then taken for more comfortable plane translation. Assistance was then derived from regional departments to postpone the plane. A plane was then created. This plane allowed us to obtain the maximum boundary. We then created another plane, same way, tossed out the old plane. Started the drawing by selecting the appropriate plane. We then drew the necessary parts and got rid of the excess parts. We then proceeded to engage in the joining process. However, the parts were formed as separate bodies. We then selected the suitable body and plane for the cutting process. In this same way, the other body was cut. We then proceeded to join all the trunks. And the drawing was started by selecting the flat surface. We then created a closed area and performed solidification with the boundary plane. A section was then taken and viewed perpendicularly to the surface. We then created a zone assignment for the conical structure. And solidified the conical structure. A joint was made and the appropriate radius value was given. And then we started drawing with the flat surface. We acquired the appropriate radius values from the drawing. Joining process completed. We then gave the appropriate radius value. We then tried the drawing for the missing part. We revised our rejoining process. We then gave the appropriate radius value to the suitable edges. And assigned zones for the conical structures. We then performed solidification and joining operations for the conical parts, and the appropriate radius values were then given. The process was completed. So that concludes our step-by-step tutorial on reverse engineering with Geomagic Design X. Should you be interested, we do offer reverse engineering services and would be more than happy to take your 3D scan data and convert it into a parametric CAD model. If you don't already have a 3D scanner, or if your 3D scanner isn't up to par and you would like for us to scan your object with our FreeScan combo, please feel free to reach out to us at info@umax.com. We would be more than happy to address your queries. If you found this video helpful, please hit like, please subscribe. It helps us out quite a bit and lets us know that the content that we're producing is useful to you. Thanks again for watching, and we'll see you next time.